So for this video, we will be looking at solving 1- and 2-step equations. In other words, we're trying to answer the question, what does x equal? Later on in the video, we will also go through a distributive property, but we will set that aside for now. So let's look at the first problem. We have to solve for x. And again, solve for x just means what does x equal? This means we need to get x by itself on one side of the equal sign, where it's x equals something. So in this case, we see that there's a 6, and we need to somehow get rid of this 6, this positive 6, so that it's only x that's left over. And we will do this by using inverse operations. And all this means is wherever we're adding in the equation, so for example, this plus 6, we need to subtract, and we will see that we'll end up subtracting 6. But just remember for now, the inverse of addition is subtraction, and the inverse of subtraction is addition. Similarly, the inverse of multiplication is division, and the inverse of division is multiplication. So let's go ahead and see this simple problem in action. We have x plus 6 equals 14. And remember, our goal here is to see, well, what does x equal to get 14? So what does x have to be that when we add 6 to it, it equals 14? And again, we just want x equals something at the end of our equation. So I'll just set this down here for now, because we know that's the goal. So again, we see this x, we want it by itself, and we have this plus 6 getting in the way. We need to somehow get rid of this. And to get rid of this positive 6, we subtract 6. And this is actually our first step. Because when we do 6 minus 6, we get 0. But that's not the only thing, because when we do it on this side, we also need to do this exact same operation on the other side. Otherwise, our equations won't be equal. Both sides of the equal sign won't be equal. So we will subtract 6 from this side as well. So just remember, whatever you do to one side of the equation, you do the exact same thing to the other. Negative minus 6, minus 6. 14 minus 6 is 8. And we didn't touch this x. This x is just going to carry down. So we'll use this, and we'll see that we'll actually get this on the first step. That's why it's a one-step equation. But now, if we see x plus 0, well, this doesn't matter. So we can actually just get rid of this. And we're left with x. Carry down that equal sign. And we're left with x equals 8. Now, we just want to check this real quick. Make sure our 8 is the right answer for x. See if our math was correct. And we did this in the previous video with substitution, but we'll do it again. We plug in 8 for x. 8 plus 6, that equals 14. So that is correct. That means that the solution to this equation is 8. X needs to be 8 for this equation, for this side to equal 14. So for this part of the video, I just want to quickly explain why we do what we do to one side of the equal sign to the other. In other words, why when we subtracted 6 from this side, did we also subtract 6 from this side? Why didn't we add? Why don't we just leave 14 as is? Now to begin, we already know that 8 was the correct answer because 8 plus 6 equals 14. So let's just plug that back in for x. And we get 8 plus 6 equals 14. And we're just going to do the exact same steps. I didn't move this. So we're going to subtract 6 from this side, but we're not going to subtract it from this side. And let's see what happens. Well, first, 6, positive 6 minus 6, that's 0. we have our equal sign, and the 14 is carried down. We didn't subtract 6 this time. If we would have added 6, this would have been 20, but either way, it would have not been correct, because when we carry this 8 down, and again, this is 8 plus 0, but plus 0 doesn't do anything, so we can actually just remove all this. We're left with 8 equals 14, and that's not correct. So always remember to subtract, or not subtract from both sides, or if you add here, add to both sides. If you divide by 6, divide by 6 here. Do what you do to one side of the equation to the other side. Because now, when we do 14 minus 6, we do in fact get 8. So for this problem, we will be solving for x for negative 6x minus 3 equals 12. And I already went ahead and set it up. And again, the goal is to get x by itself on one side of the equal sign using inverse operations, like we did in the first problem. So the first thing is we see that this x is here, and we somehow want to get this x to look like this, just 1x. But we see that it's attached to the negative 6, and there's this minus 3. So the first thing we'll do is we'll get this term with x in it by itself, and we'll get rid of this negative 3 or minus 3. So again, step number 1 is doing the inverse of minus 3 is positive 3, so plus 3. So we add plus 3, and this is going to give us 0. And remember, we need to do this plus 3 to both sides. So we did plus 3 here, and we'll do plus 3 here. And this will just give us 15. Awesome. We'll carry down this equal sign. We'll carry down this minus 6x. So again, this means negative 6 times x. Okay? And one more time, with this plus 0, that doesn't really mean anything because it'll still be this. Anything plus 0 is still anything. So we'll actually get rid of this so we don't confuse ourselves. And I'll go ahead and bring these together. Great. So we now have just the term with x in it. So we're almost there. The next thing we need to do is this negative 6 is in the way. So we need to, since this is being multiplied, we need to divide by negative 6. That way we're left with x by itself. So that'll actually be our second step. We want to divide by 6, and it is very important that we do this negative 6, because if we were to do negative 6 divided by 6, you would be left with negative x, not positive. So negative 6 divided by negative 6, that's just 1. So 1x, and that's just x. And again, do what we do to one side to the other. So this turns into, we need to, well, first divide by negative 6. And that actually will give us our final answer, which is negative 15 over 6. And it's okay to have fractions as answers. Negative 15. And so with that, we'll just bring this down here. We get x equals negative 15 over 6. And this will be our final answer. So to recap, we added 3 to both sides because this is a negative 3, a minus 3. And when we added that, this cancels out, and we're left with negative 6x. We also added the 3 this way. We got 15. And then to get x by itself, like it is here, we divided by negative 6. Not positive 6, negative 6. To just get x by itself. And then 15 divided by -6. That's just a fraction. That doesn't give us a whole number, so we can actually just leave it like this. X equals -15/6. Great. So now we have this equation. We have 3/2 times x minus 4 equals 6. And it's basically the exact same thing we've been doing, except now we have a fraction. So we will do the same thing by using inverse operations to get x by itself on one side of the equal sign. So again, we want to get to this point where we do some steps, and we get x equals something. So again, we want to get this x by itself, but there's this -4, this -4 that gets in the way. So the first step is going to be to add 4. So that way when we do -4 plus 4, we get 0. And remember, whatever we do to one side of the equal sign, we need to do it to the other side. So we will add 4 to this side. And 6 plus 4 is 10. 6 plus 4, 10. We carry this down because we didn't do anything with that. So let's bring this over here. That's a big number. And we can see that 3/2x plus 0, well, this can go away because it's not going to do anything. So we can just put it aside. And we're left with 3/2x equals 10. So we'll bring that over just so we can see it clearer. So now we need to get x by itself. Remember, we wanted this x by itself, but this number, this 3/2, gets in the way. So I'll show one way that you can do this, but it'll actually take one more step than necessary. So the first thing we can do is, we know that fractions, this 3/2 means 3 divided by 2. And another way to write this is 3 times x divided by 2. That's all, it's the same thing. So what we can do is we can multiply both sides by 2. So this will be our step number 2. And when we multiply by 2, what's actually happening is we have 2 times 3 times x all over 2, but these two cancel. 2 divided by 2 is 1, so that's going to just leave us with 3x. And on the other side, we still need to multiply by 2 because we did that on this side. So we do 10 times 2. And 10 times 2, when we do that, we get 20. So to recap real quick, 3/2 is the same as 3 times x divided by 2. And that divided by 2 we want to get rid of in this step. So we multiplied by 2, which means that the 2's cancel. Again, this was up there. 2 divided by 2 is 1. So you're just left with 3/1, which is just 3. So you get 3x equals 20 now. Now, the last step is what we've been doing. We have this 3x, so we already know that this is 3 times x. So the inverse of multiplication is division. So we get 3 divided by 3. And 3 divided by 3 just leaves us with x, because 3 divided by 3 is 1. 1x is the same as x. But now we have to do it to the other side as well. 20 divided by 3. We did 3 divided by 3, 20 divided by 3. And the thing about this is that this can't be reduced anymore. This 20 divided by 3 will give us a decimal. So it's perfectly fine to just say 20 divided by 3 is 20/3. because that's what fractions are. So we can see here that we multiplied both sides by 2 and then we divided by 3 and we got the correct answer. But in fact, that was 3 steps. So this would really be solving a 3-step equation. However, there's one way you can do it where you only do 2 steps, and that is by multiplying by the reciprocal of this fraction. And the reciprocal just means the opposite. So the reciprocal of 3 over 2 is 2 over 3. So let's see this in action. Here, I will move this for now. But here we saw we multiplied by 2, multiplied both sides by 2, and then we divided by 3. And to make this clear, we know that when this line is between 2 numbers, that's just division. So I'm just going to swap that. And now we can clearly see that in fact, in 2 steps, we ended up multiplying by the reciprocal of this number. We did the same thing over here. We multiplied by 2, and then we divided by 3. And well, that's just 2 over 3. Multiplying 2 over 3. So we'll go through the steps again so we can see this clear, exactly what is done. So here, instead of multiplying by 2 first, we're just going to do this at the same time. We're going to multiply by 2 over 3, the reciprocal. All we did was just flip this. And in doing so, this is what it really means. 2 times 3 divided by 3 times 2. These cancel. And you can see this because 2 times 3 is 6. 3 times 2 is 6. And 6 divided by 6 is just 1, which means you just get x. So I'll bring this back down. So this is our step 2. But since we did it to this side, we also need to do it to this side. So in doing so, we're doing it like this. Let me just move it up here so you can see it clear. You get 10 times 2, which is 20. And then all that is over 3. So at the end, you get, you're left over with x, because these canceled. So you're bring down that x. You get x equals 20 over 3. And that's the exact same thing we got by doing the other method, just with 1 step less. So you pick. You can either multiply by the reciprocal, or you can multiply by the denominator and then divide by the numerator. Either way, you will get the exact same answer. So just pick whichever method you're more comfortable with and stick with it. So now we will be looking at the distributive property. So we will be looking at this equation, and we still want to solve for x. And the equation is 2 times, whenever you see a 2 next to a parentheses, that means multiplication. So 2 times x minus 3, and that's going to equal 6. And we, again, want to get x by itself on one side of the equal sign and get everything else on the other side. And that will be solving for x. First of all, when you see parentheses in a problem, you should go directly there. Your eyes should immediately go there. And this is because of PEMDAS. The P in PEMDAS means parentheses, and that means everything inside the parentheses should go first. In this case, x and minus 3 are not like terms, so we cannot combine these in any way. And the other thing I like to think of parentheses is as a telescope, or one of those things that like pirates have that expand and they can see out into the ocean. Because if you had multiple parentheses, you would start off with the very center and work your way out. But anyways, we only have one set of parentheses here, so it's very simple. So now the distributive property says you distribute the 2 with everything inside the parentheses. And again, a distributor, think of it as someone that gives out things. For example, your teacher could be a distributor if he or she gave out a pencil to every single student in the classroom, or a notebook to every single student in the classroom. Someone that gives something to everyone. So in this case, we're going to take the 2 and we're going to go with the x. And the 2 and the x is going to give us something, which we will see in a minute. And then the 2 is going to go with the -3, and it'll give us something. You probably already know what it is, but let's see it in action. So again, first step is to distribute. When we go with the 2 and the x, we're multiplying, because remember, 2 next to a parentheses is multiplication. So 2 times x, it gives us 2x. And then now we want to take the 2 and go with the -3. So we want to, for each term, so we get 2x, and then we add whatever this is, 2 times -3. That is very important that you remember that sign. So we get 2x plus 2 times -3. And 2 times -3 is -6. So we'll put the -6 there. And now 2x plus -6, that's just 2x minus 6. So this is the distribution right here. When we took the 2 with the x, we got 2x. And when we took the 2 with the -3, we got -6. On this side of the equation, we did not do anything, so we still get 6. We just carried this down. And now we can go into step 2 and solve this like any other equation we've done. First, we want to get x by itself, but this -6 gets in the way. So we'll do the inverse and add 6. Because when we add 6, we get 0. And we have to do it to the other side as well. So we add 6 over here. And on this side, we get 12. Now let's finish by carrying everything we haven't touched down. So we didn't touch this 2x, so that comes straight down. And remember, this is 2x plus 0, but this doesn't do anything. Plus 0 is still, 2x plus 0 is still going to be 2x. So we can just get rid of this. So now we have 2x. And on the other side, we have 12. So we have 2x equals 12. Now we go on to step number 3. And that's just simply getting x by itself. So 2 times x, the inverse of 2 times x is to divide by 2 to get x by itself. So let's divide by 2. And again, we have to do that to both sides. And this, when we divide 2 divided by 2, that gives us 1. 1x to be exact. And that's just 1. And now, when we divide 12 by 2, we get 6. And we can verify this by plugging 6 back into here. So if I take this 6 and I replace it for x, we can now see that 6 minus 3 is 3. And then 3 times 2 is 6. So we know we did the correct thing and got the right solution. So now we have a bit more of a complex problem. We have -2 plus 4 times x minus 3 equals 12. And again, what I said in the last problem, our eye should immediately go here and see if we can combine like terms or do if there's any PEMDAS operations we can do. But here it's just x minus 3 and we can't do anything else. So we'll distribute right away. So here's the problem. And as I mentioned, our first step is going to be to distribute. This -2 is by itself. This is not right next to the parentheses, so this does not play a role in the distribution. So that is just -2. But now we have +4 times +x. That's just +4x. So I have this plus that corresponds to the +4x. Now we have +4 times -3. That means that this is now -12 or -12, however you want to look at it. But this is crucial, keeping these signs to correspond with these signs. +4x and then +4x times -3, which is -12. So on this side, nothing changed, so we'll just bring that down. So that was our first step. Now, on this side, we can combine like terms. We can combine these two numbers because they're both numbers. And when you combine like terms on the same side of the equal sign, so on this side, you can just simply combine as is. The only time you do an inverse operation is when you cross over here, cross this equal sign. For example, if we wanted to combine these two, this -12 and this +12, that's when we add, because it's the inverse of subtraction. Add 12 to this side, but you should always try to combine like terms on the same side first. It'll make things a lot simpler. So that'll be our second step. -2 minus 12. I'll move these like this so it's clear what we're doing. -2 minus 12. Well, if you're at -2 on the number line, and then you subtract 12, you go further left. And that's just -14. And I'll go ahead and move these back so we can keep it the same as it was before. But now we know that -2 minus 12, that's -14. We did not do anything with this 4x, so that is still +4x. And again, we didn't touch anything over here, so this just equals 12. So now, step number 3. Now we can combine these like terms to get this x by itself. Now that we have combined everything on this side, we want this x by itself. So we're going to move this over here. And again, by moving over the equal sign, you do the inverse. Because -14, and the inverse of -14 is +14, so -14 plus 14, that's 0. And we still have this plus 4x. And now what we did to this side was plus 14. So we must do plus 14 over here. That is a rule. There's no exception to that. So here is 12 plus 14. Carry that equal sign down. And 12 plus 14 is 26. And once again, 0 plus 4x is just 4x. So we can move this. But I will keep it this sign, this positive 4x, just to remind us that it is in fact a positive 4x. So finally, step number 4 is just to get the x by itself, to get x equals something. So the 4 is attached to the x, so we must do the inverse, and I'll actually move this now that we know that this is positive. The inverse of multiplication, because 4 times x, is division. So now we divide both sides by 4. And since we divided by 4 over here to get x by itself, because 4 divided by 4 is 1, 1x is the same as x, we get x equals 26 over 4. And so that's just a fraction, which is 26 over 4. But this can be reduced if you divide 26 by 2 and 4 by 2. 2 times 2 is 4, and 13 times 2 is 26. So 26 over 4 is the same as 13 over 2. So we can just replace these, and we get 13 over 2 as the answer for x. Now, if you want some additional practice, I recommend you go back and plug this answer in for x and see if after you do all this math, you get 12.